And just record the rest of this, I guess. Okay, so what you have on this one is we have our zeros. We want to go ahead and write this in a factored form. Okay, how many zeros am I going to have on this if it's degree 3? Good, you're going to have 3. How many did I give you? 2, but you can figure out the other one, can't you? Okay, so one of your zeros is 3. Remember, you always start by putting x minus whatever the 0 is. That's the structure. Okay, so what you're going to have is you want to put each of the zeros in those spots right there. So x minus 3 would be 1. The next one would be, let's put in -6. Oh, hold on, I got the wrong thing there. I'm not looking at the problem right, sorry. Okay, the first 0 is 1 plus I, not 3. 3 is the degree, so we're going to go 1 minus parentheses 1 plus I. Now, you got to have the 1 plus I in parentheses because it's x minus whatever that 0 is. Okay, if 1 plus I is a 0, then what else is a 0? 1 minus I, good. So you're going to put x minus 1 minus I like that. Okay, and make sure you have that in parentheses. And then the next one is -6. So again, put x minus -6. So I have x minus 1 plus I, x minus 1 minus I, x minus -6. Everybody with me there? Okay. Now let's simplify this a little bit. So distribute the -3. That's going to give -1 minus I. Okay, when you go to the next one, we're going to have x minus 1 plus I. And then over here, we're going to have x plus 6. Okay, now we're going to multiply this out. Okay, now this is going to be a little more work than the last problem. Okay, it's not hard, but it's going to be a little bit more work. So the first thing I'm going to have you do is we're going to multiply these two things together. We're not going to do anything with the x plus 6. We're just going to multiply this out, then take the result times x plus 6. So watch this carefully. This is not FOIL, but what you got to do is you got to take x times everything, -1 times everything, and -I times everything. So you got to do 9 multiplications. It's not hard, but you just got to do this in kind of a logical order. So to begin with, I'm going to do x times x. That's x squared. Just kind of carefully do this with me. Then we have x times -1 is -1x. And then x times I is plus xi. Doesn't matter if you write that as ix or xi, it's all the same. Okay, then I'm going to take the -1 times everything. So -1 times x is -1x. -1 times -1 is +1. -1 times +I is -I, or -1I. Now take I times everything. So now I take -I times x. Okay, then I take -I times -1 is +I. And then finally I do -I times +I. That's -I to the second. Then I got x plus 6. Okay, now again, what I did on that, it's not a hard thing to do. It's a lot of work. You got to take x times everything, -1 times everything, -I times everything. Okay? Does anything look like it cancels or anything anywhere? Let's see. Looks like those i's cancel right there. Does anything else cancel? These do. xi and ix, those are the same. Okay? And then it looks like we have a couple of like terms, so you would have x squared. And see, these things go together. Those are like terms. So we're going to have -2x when you put that together. Okay. Then we got a +1. But tell me what I squared is. -1, right? Okay. Remember, when you see I squared, you're going to get -1. So you're going to have minus -1 like that, and then bring down the x plus 6. So what I did from there is I canceled everything I kind of wrote in red, just canceled, but then I have the 2x goes together, and then 1 minus -1. So that's going to be a +2, isn't it? Because that's going to be 1 plus 1. So what you're going to end up having now is you'll end up having this. You'll have x squared minus 2x plus 1. Now we're going to multiply that by x plus 6. That's the hardest, messiest part of the problem, is multiplying that stuff out. Okay? Is everybody okay with what I did? Yeah.
What do you mean +2?
+2. I even said that, didn't I? I think I did anyway. Yeah, 1 plus 1 is 2. Yeah, that comes from this part right here. Thank you. So that would be +2 like that. Okay, now let's go ahead and multiply it out. So now we got we're just going to take x squared times x. So x squared times x is x to the third. X squared times 6 is plus 6x to the second. Now do the same thing with negative 2x. So negative 2x times x is negative 2x to the second. Negative 2x times 6, negative 12x, and then multiply the 2 by everything. So 2 times x is 2x, and then 2 times 6 is plus 12. Okay, we put our like terms together. You're going to have x to the third. And see, those are like terms. They go together, and then the x's go together. So when you put that together, 6 minus 2 would be plus 4x to the second. And then negative 12 plus 2x is going to be minus 10x plus 12. So that is the function that has those three zeros. Okay? Now, what I want to show you on this, I also want you to do this on your calculator, because I want to show you kind of what happens. I try to use these problems to give you an idea of how the complex numbers relate to x-intercepts. Okay, what did you learn about x to the third? What does its graph look like? It's like this, okay? So in this case, since that leading coefficient is positive, when you do this with a calculator, it's going to do this. It's going to swing up like that and go like that. What is that 12 going to tell you? That's the y-intercept. So it's going to have a y-intercept of 12. So let's just kind of use the same viewing window, and let's put this in. So we'll have x to the third. Let's go ahead and put it in your calculator. You can use the same window. And then plus 4x to the second. And minus 10x. And plus 12. Okay, I'm just going to do the same viewing window for whatever we had in the last problem. Actually, we may have to adjust that. So do your window button, and let's go negative 10 to 10. But you can leave the y's the way it is, because that'll show you what I want you to see anyway. Okay, so you should see the endpoint behavior you want, but my question is, let's look at how many times it crosses the x-axis. So what our zeros were, our zeros are negative 6. Is that a real number? So that means it's going to cross at negative 6. Okay, how about the 1 plus I, 1 minus I? It won't cross. Okay, so these are not x-intercepts. So what you're going to find on this, when you type graph, you should see it only touching the x-axis one time. So it touches at the real 0, but the other two it doesn't touch it. That's what I want you to know. Okay, does that make sense to you? Okay, kind of like the last problem had all complex numbers. That's why it never crossed the x-axis. So by looking at that problem, you would know what that looks like. Okay, does that make sense to you guys or not? Okay, all right, so you want to know how that affects your x-intercepts. Okay, so now let's go to the next page. Now what we're going to do on this, I'm going to go ahead and set this up, then I want you to take a few minutes and see if you can multiply this out, because I do want you to try one of these in class just to see where your skill is. Okay, so the zeros on this would be 4i and negative 4i. You would know that, and negative 5i and 5i. Okay, so when we put this together, you want to write this like this. Remember, you're going to have 4 factors, 4 sets of parentheses. So what you're going to have is you always have x minus. You want to go ahead and write that down like that, and then put in the zeros. Okay, so the first 0 is, I gave you, was 4i. Okay, that means you would also have negative 4i. Also gave you negative 5i. That means the complex conjugate would also count. Okay, so we have that. Now I'm going to clean this up, and I'll kind of explain what I want you to do. Then I want you to go for it. So this is x minus 4i, x plus 4i. Then you'll have x plus 5i, and x minus 5i. Okay, now I want you guys to go ahead and multiply that out. Now do it this way. Multiply these together, multiply those together, and then remember when I squared pops up, that's going to be negative 1. Okay, so go for it. Don't wait for me. You need to do something. Okay, everybody do that. You okay there? Okay. when you get an answer, I want you to put it on your graphing calculator. I'm going to show you one other thing that you can do on some of these graphing calculators too that can verify your answer. I'll show it on this one in just a minute. Now remember, you can do the shortcut if you're doing x minus 4i times x plus 4i. You just got to do the first and last terms, because the inner and outer are going to cancel out anyway, so that saves you a little bit of time if you do that. And I want to show you that your calculators, most of the time, they can work with I. Sometimes it'll work on this, sometimes it won't. But to begin with, let's go ahead and let's graph this. So we have x to the fourth. And then let's see, we have plus 41x to the second. And then plus 400. What does the 400 mean in this problem? It's y-intercept. Okay, so that means we better adjust the window. Okay, so I'm going to leave the x's the way they were, but we need to go up past 400. So this time I'm just going to say like negative 1,000 to 1,000. I mean, it doesn't really matter. It's just I want you to see a certain thing on this. Okay, so I'm going to scale that like negative 1,000 to 1,000 by maybe 100. Okay, now it's a fourth degree polynomial, so it's going to do this, right? Okay, leading coefficient's positive. Okay, is it ever going to touch the x-axis? No. No, how come? Because all of the zeros are complex, right? There's 4 zeros, they're all complex. So when you graph this on the calculator, you aren't going to see it crossing the x-axis at all. You're going to see it having that y-intercept of 400, but all 4 zeros are complex, that's why. Does that make sense? That's important. That's the number one connection I want you to make. Now, I want you to try this. Sometimes this works on calculator, sometimes it doesn't. But if you look at your decimal point, most of you are going to have the letter I on top of that decimal point. If you have a TI 83 or 84. So if you want to check your answer on this, you can actually do this. I'm just going to have you check one of these answers. So we're going to go to our answer, which is x to the fourth. 41x squared plus 400. We're going to plug in one of the zeros. Let's plug in 4i. So what you would do is you would go parentheses 4i. To get I to come out, you go second decimal place. Then close parentheses, and then raise that to the fourth power. Okay, your calculator should work that out. Some of the older ones don't. Then we're going to do plus 41. Okay, and then again go through and do parentheses. Now replace x with 4i. So you go 4 second decimal to get that to come out, close parentheses and square, and then plus 400. So actually, your calculator can generally do this. Okay, so if you press enter, you should get a 0 if your calculator works correctly, that is. So what I'm doing is I'm just checking that 0 so it worked. Did that work for those of you who tried that? Every now and then, it'll have something kind of weird like in scientific notation or something, but sometimes it'll come out right as 0. So you know negative 4i is correct because it's the complex conjugate theorem. You could do the same thing with 2i or negative 5i, and you could prove you're right. So basically all 4 of those zeros should check on your calculator. Okay, does everybody understand that? Okay, so that's kind of a worthwhile thing to learn how to do with your calculator. Okay, now the next thing I want to go to is we've got this polynomial function, and this is kind of like you did on the last test. I gave you a 0, so you found the other zeros. Okay, so what we're going to do on this one is, how many zeros is this going to have? What's the degree of this polynomial? 4. So the maximum number of zeros is 4. I've already given you 1, so we got to find the rest of them. Okay? Well, negative 2i is a 0, so what does that tell you another one has to be? 2i, good. So that's one of them. Okay, so what we're going to do is we're going to do synthetic division. Okay, so what we're going to do is we're going to start by dividing by the 0 I gave you. We hadn't done this yet, but we can do this. We can divide by negative 2i. Now, under this, does this have any missing terms? Yeah, it's got a third power missing and an x. So you got to go 1, 0, negative 21, 0, and then negative 100. So you got to make sure that you pay attention to that. Now what we're going to do is we're going to synthetically divide. Some of this you may have to do some little scratch work on the side of your paper. Okay, so you bring down the 1, multiply negative 2i times 1 is negative 2i. Add the column, so 0 minus 2i is minus 2i. Okay, now multiply. Some of this I'm going to do at the side. So if I do negative 2i times negative 2i, you're going to do this in your head, but I want to show you what I'm doing. That's 4i squared. So what is it? Negative 4, right, because I squared is negative 1, so we're going to have a negative 4 like that. Okay, right? Then we add the column, so that would be negative 25. Then we multiply, so now we're going to multiply negative 2i times negative 25. Okay, well that is 50, positive 50i, right? Add the column, that would be 50i. Now multiply, you're going to multiply negative 2i times 50i. That's going to give negative 100i squared, so what is it really? 100, right, because remember I squared is negative 1, so you have negative 100 times negative 1, so that's 100. And I told you it was a 0 anyway, so hopefully you were expecting that to happen, okay? All right, so we have to start that way. Now what we have to do is the next thing is take the result. Remember, this is a remainder right there. So you just need to divide, go ahead and bring everything down. 1, negative 2i, minus 25, and 50i. Okay, so the other 0 is 2i. So divide by 2i now. Okay, so you got to divide again, and we know that it's going to be a 0 by the complex conjugates theorem. Okay, does that make sense why I'm doing that? Okay, I can say I gave you negative 2i is a 0. You know that 2i is also has to be 1 because they come in pairs. Okay, we go ahead and finish this up. Bring down the 1. 1 times 2i is 2i. Add the column, that's 0. 2i times 0 is 0. Add the column, that's negative 25. 2i times negative 25 is negative 50. So the remainder is 0 like we thought it would be, right? Okay, so now we got to get the two other zeros. So what we have here is, remember, this is a remainder, and if you go backwards the way we've already learned, that's a constant term. This is x to the first. That's x to the second. Okay, so I've divided 2 times so that x to the fourth has gone down 2 powers to x to the second. So what you're left with is x squared plus 0x minus 25. So if you're going to write this out, then what you have is x squared minus 25. And then we need to use that to find the other two zeros. So what you'll have from here is you'll have x squared minus 25 is 0. Now you need to solve that equation. Okay, that equation's easy to solve. You can either factor it or you can do the square root property. So if I do that, I'd have x squared equals 25. Square root of both sides. If you do that, don't forget your plus and minus. So the other two zeros are 5 and negative 5. Okay, that's how I did that. All right, now let me ask you a question on this now. Okay, first of all, what we're doing, we're not going to do anything with the graphing calculator. All right, so what is that graph going to look like, just roughly? It's going to do this, right? Okay, what's the minus 100 going to tell you? Y-intercept negative 100. How many times do you think it's going to touch the x-axis?
Twice.
Okay, twice. Which ones is it going to touch at? Yeah, the real numbers. So you're going to have x-intercepts at 5 and negative 5, but the 2i and negative 2i are not x-intercepts. Okay, that's how that goes. Okay? Does that make sense to you? Okay? All right. So that's how that goes. All right, I'm going to do another one like this. This one's a little harder to do. So I give you a 0 to start you off on this then, okay? All right, this is a third degree polynomial. So that means the maximum number of zeros is 3. So we're going to take this one and we're going to divide it, okay? So we're going to have 3 zeros. So we've already got the 1 plus I. So what's another one have to be? Yeah, 1 minus I also has to be 1. Now we got to find the other one. So we do have to synthetically divide. So we're going to take 1 plus I, and we're going to divide this into the polynomial. There are no missing terms, so it looks like we have 1, 7, negative 16, and 18. It's not a bad idea to kind of spread that out a little bit. And then we're going to do synthetic division. You already know if I gave you the 0 that you're going to have a remainder of 0. So if you don't end up with a remainder of 0, you're probably messing up. Okay, so I just bring this down. Okay, then I multiply. If I do 1 times 1 plus I, that's 1 plus I. Okay, when you add the column, it's just kind of like adding like terms. So 7 and 1 are real numbers, so that's going to be 8 plus I, like that. Okay, now you want to do a little bit of scratch work on this. The next thing you're going to do is you're going to do 1 plus I times 8 plus I. So let's go ahead and let's work that out. Okay, so you're going to FOIL this. You're going to multiply this out by FOIL. So the first term, 1 times 8 is 8. Outside term, you would have 1 times I or I. Inside term would be 8I. Okay, and then the last term would be I squared. Okay, what are you going to do with the I squared? Negative 1, exactly. So you're going to get 8 plus 9I. Those are like terms. And then the I squared is going to become minus 1. So you're going to have 7 plus 9I. Okay, so that's going to record right here 7 plus 9I. That's kind of hard to do that in your head, so you may have to do a little scratch work at the side like that. Okay, all right. Now we add this, so negative 16 plus 7 is negative 9. Then we have a 9I like that. Okay, now we got to multiply, so we need to do this, on scratch paper. So I'm going to do 1 plus I times negative 9 plus 9I. I'm just going to go ahead and FOIL that out and show you what happens. Okay, so if I do this, I'm going to have the first term is negative 9. Outside term is 9I. Inside term is negative 9I. And then last term is plus 9I to the second. Okay, what happens is that cancels. So you've got negative 9. And again, what's I squared? Negative 1. Okay, so you replace I squared with negative 1. So you get negative 18. And then that gives us a remainder of 0. So we knew that was going to happen anyway, right? Okay, but you have to do that in order to get ready for the next step. Okay, is everybody okay with what I did there? Now this stuff right here, you probably have to do that a little bit at the side of your paper because it's hard to multiply complex numbers out in your head. You got to FOIL and go through the details. Okay, next thing you're going to do is this is a remainder like we expected. You want to bring this down. This is going to be 1, 8 plus I, and negative 9 plus 9I. What's another 0 that we know? So we're going to divide by 1 minus I. So we're going to do it again. Okay, we've got to find 3 zeros. So we got one more to find. Okay, so we're going to run through this then. Okay, this works the same way. Bring the 1 down. Multiply 1 times 1 minus I. That's going to be 1 minus I. Okay, when you add that together, what are you going to get? 9, just 9 plus 0I, or just 9, good. Okay, now we multiply this. Now you can do this in your head. You're just doing 1 minus I times 9. So that's going to be 9 minus 9I. So I put that as 9 minus 9I. That gives a remainder of 0 like we expected to get, say. Okay, so now I've got 2 zeros. I got to find the third one. So what you got to realize on this is the remainder. That's a constant term. And then that is x to the first. So what you have is you have 1x plus 9. That's what you get out of that. Then you set that equal to 0. Okay, so what's the last 0? Negative 9, good. Okay, so you can solve that in your head. So x is equal to negative 9. Okay, all right. Now, if you look at the polynomial I gave you, it's an odd degree, so it's going to do this. Okay, can you tell me, out of these zeros, how many times is it going to touch the x-axis? One time. Where is it going to cross? -9. Good. Okay, that's the big thing I want you to kind of get out of what we're doing, because you're trying to develop a greater understanding for functions. Okay, that's the idea. Okay, so I'm going to start you off on this one and then give you an opportunity to finish this one. Okay, so I've given you the first 0. Now you're going to have 3 zeros since it's a third degree polynomial. And you're going to start by dividing by -4. That's a real number. There's nothing missing. So what you guys want to go ahead and do is see if you can finish this up now. Okay, now by the way, a lot of students will think that 4 is a 0. It doesn't have to be. -4 is a real number. Those things do not necessarily come in pairs. Okay, so go ahead and finish that. Then you'll have a quadratic equation to solve, but you'll probably have complex numbers. So I want you to go ahead and see if you can finish that up. This is pretty similar to what you did on your exam, except I designed the problem so they didn't have complex number solutions. Now they're going to have them. Okay. So you may have to do the quadratic formula on this also, so I'll write the quadratic formula up here too, because you're going to need it probably in this problem. Did you get a remainder of 0?
Yes.
You didn't? Really?
Yeah, I don't know where I messed up.
Okay, all right, let me make sure, because I'm going to make sure I didn't mess up. Okay, so I'll bring a 1 down. Multiply, that's -4. Add, that's -6. Multiply, that's 24. So that's 13. You made an arithmetic mistake. So yeah, you got a remainder of 0. Okay,
Yeah,
all right.
26.
Okay, all right. Okay, so what you have is you have a remainder of 0. What's the 13? What is that? Constant. What's the 6? -6x. And then what's the 1? 1x to the second. Yeah, so what you have is you have x to the second minus 6x plus 13, and then you want to set that equal to 0. Okay, now the thing on that is you're going to have to go the quadratic formula because it does not factor. And we haven't done a lot with the quadratic formula with complex numbers yet, so let's just do this together. So basically a would be 1, b would be -6, and then c would be 13. So if I put this together, I'm going to have -b, so that'll be -6, plus or minus the square root of b squared, so that's -6 squared, and then 4 times a, which is 1, times c, which is 13, and all over 2 times a like this. Okay? All right, so let's see what we get when we work this out. So we're going to have +6, plus or minus, and under the radical it's going to be 36 minus 52. 4 times 13 is 52 over 2. Okay, now what happens when you do 36 minus 52? What kind of number do you get? You get a negative number, and that's why this is going to be a complex number. So that's going to be, what is that, 16? That's what I thought. So that's -16 over 2. Okay, so we haven't really done anything much with complex numbers. So if you have the square root of -16, this is really the same thing as the square root of -1 times the square root of 16. So the square root of -1 is I, and the square root of 16 is 4, so it's 4i. Okay, so you write that as 4i. So if you have an imaginary number, if you have a negative under the radical, you have to write this like this. So this will be 6 plus or minus 4i over 2. And see, the reason they come in pairs is because of the quadratic formula has the plus or minus. It's guaranteeing that they're coming in pairs. So what you'd do is split this up. You have 6 over 2 plus or minus 4i over 2. So that's going to give 3 plus or minus 2i. So that means your zeros, let's see, I gave you negative 4. So we found 3 plus 2i is 1, and the other one's 3 minus 2i. Okay, like that. Okay? How many times is this going to cross the x-axis? One time. There's only one real zero, so it's going to cross one time. Okay, does that make sense to everybody? Okay, so what you'll deal with in this sometimes is when you're dealing with the quadratic formula, you may end up with complex numbers. That's the idea. Okay, so let's go to the next page and let's see if we can finish this up here. The only thing I want to do with this is just kind of remind you of the P or Q thing, but we're going to end up mostly on this using a calculator to find one of these anyway. Okay, so with this, P is all of the factors of 9. So what are the factors of 9? 1, 9, and 3. And you got to put the plus or minus. So we'll put plus minus 1, plus minus 3, plus minus 9. Q would be all the factors of 1. So that's just plus minus 1. Then if you do P over Q, you just do 1 over 1, 3 over 1, 9 over 1. So you're going to have 1, 3, and 9. Those are your potential zeros. And again, this is the third degree polynomial, so you're going to have a maximum of 3 zeros. Okay, so what I would suggest you do, when you do this on your homework, don't randomly try to divide these numbers in. Get your calculator out and see if you can find a 0. Okay, so let's go ahead and just do this together and do this in a standard window. So I have x to the third. And then I have, let's see, minus x squared and plus 9x. And this is a third degree polynomial, so you know what it's going to look like. And then minus 9. And then just go standard window so you can go zoom 6. We'll put you back into just a basic window. Okay, so let's see if we have anything. Okay, it looks like it crosses one time. So that probably means that we have one real zero that it looks like 1, right? Okay. The other two are probably complex. What do you think? I mean, unless the zeros are way out somewhere that I am not seeing, but I don't think that's the case. So what we'll have on this is let's go ahead and let's take 1. It looks like 1 is a 0. We get that from the calculator. So let's go ahead then and let's just divide this out. So we have 1, negative 1, 9, and then negative 9 like that. Okay. So we're going to go ahead and do that. The synthetic division on this is pretty straightforward. Bring the 1 down. 1 times 1 is 1. Add the column, that's 0. 1 times 0 is 0. Add, that's 9. Okay, so we ended up getting a remainder of 0. Okay, so what we're left with is, this is a constant. This is x, and that's x squared. So what we're left with is x squared plus 0x plus 9, which is just x squared plus 9. Now you set that equal to 0, then you solve that equation. Okay, does that factor? X squared plus 9 equals 0? Yes. Students a lot of times think it does. It doesn't factor like x plus 9x minus 9. Okay, what you're going to have to do on this is the square root property. So you need to move the 9 to the other side to get x squared equals negative 9. Okay, now you do the square root of both sides. And when you do that, you got the plus or minus there. How do you write the square root of negative 9? 3i. Remember, the square root of 9 is 3, right? But it's an imaginary number, so you're going to write that as plus or minus 3i. Okay? So that means the zeros are, we got 1. That came from the calculator. The graphing calculator clearly gave us that real 0. Then we have 3i and negative 3i. That came from doing the synthetic division. Okay, does that make sense to you? Okay, it's kind of like the last problem. We just did the synthetic. We ended up with complex numbers. So now if you go to a factored form, it'll go like this. Okay, so we're just going to write 3 factors because we have 3 of these, and the structure is always x minus something. So it goes like that, and I'll just plug in the zeros. So one of the zeros is 1, the other one's 3i, the other one is negative 3i. Okay, so what you'd end up doing, and you can do this in your head, you have x minus 1, x minus 3i, and then x plus 3i. X squared plus 9 factors, but it factors through complex numbers. So that's how that goes. Okay? All right? Does that look okay? All right? Okay? All right? This last one, I don't think I have time to do the last one, so I think I'm just going to put that off till next time, because that's a 4th degree polynomial. It takes a little bit longer to do. So bring this next time, and then we'll do this. Now, did you guys work a little bit on your application problem today?